So we are recording, just in case anyone was not sure. So welcome everybody, and I really appreciate you taking time out of your day to join us. Just a few reminders, if you can keep your camera and microphone off, there'll be an opportunity to speak questions a couple times during the video conference, so that we will put up a slide that will make that clear and transparent to you. Otherwise, please, at any point in the webinar, you can drop your questions into the chat, and we have folks monitoring those, and we will get to them. Fundamentally, I view this webinar as really the place to ask questions. So that's the most crucial part, right, where you can ask something very targeted. We will post these slides, and there will be a video version of this presentation posted on the DOEleadershipcomputing.org site after we are finished. All right. Okay, so who am I? Who's talking today? So my name is Katherine Riley. I am the INCITE Program Manager. I am also the Director of Science for the Argonne Leadership Computing Facility, which also has a role in how INCITE is run. I have been part of INCITE actually since the INCITE program started many, many years ago. Also speaking today will be Kyle Felker, who is a catalyst, one of the computational scientists experts at the ALCF, and Dyma Bykov, who is sort of a similar, he's called the liaison, but he is the computational science expert at the Oak Ridge Leadership Computing Facility. So thank you, both of you, for helping out today. What are we doing? Why are we here today? So the primary objective is to help you learn about the key components of INCITE and leadership computing facilities, and share with you what we really consider the best practices and our experience in writing INCITE proposals. We'll also walk through the key sections of the proposals just to make sure that people understand what we're looking for within those sections, and try to give you a sort of a target for what you might do as you're writing. Some key timelines, you'll see these more than once over the course of this presentation, but new proposals for INCITE are due June 14th at the end of the day at 5 p.m. Central Time, US Central Time. That's a little bit over a month from now, so 5 weeks from now. A renewal proposal is due later in the year. They're due on July 19th. You would have already received an email communication from me telling you that you should be preparing a renewal proposal. And if that doesn't make sense to you because you're new to the process, I'll explain what renewals are as we go forward. And then in the larger time frame, right when proposals close on June 14th, we really start the process of processing the proposals and really kickstarting the assessment and review process for INCITE. And that goes pretty much all summer. So PIs will be notified early November. So this is normally before supercomputing for those who know when that is. So you'll know early November, and that triggers a sequence of events engaging with your facility to get access to start your award on January 1st of next year. All right, as I mentioned, there are new and renewal proposals. So a new proposal is for someone who does not have a currently active proposal that is eligible for renewal. So you might have one, but it's ending, and so a new proposal is required. New proposals can be for 1, 2, or 3 years. And the requirement really for that is really that the PI with the current, you will need to be a PI, right? Applying against this new proposal, and that you're not eligible for renewal. There are scenarios that I'll get to where somebody might be eligible for a renewal but chooses to step away and submit a new proposal. So for a renewal, those are PIs that have previously been given a 2 or 3 year award. So they're moving into asking for their second year or their third year. So that's a 1 or 2 year time frame. The questions we ask in the renewal are slightly different. They're really targeted on making sure that projects stay on target for what the original proposal was targeting. And so as I mentioned, the deadline for new proposals, June 14th, 5 weeks from now, and July 19th for renewals. So that's another month out. The one thing to consider, this comes up a few times, is with renewals, you do need to stay within the scope of the new proposal. So there are times in conversations I have with PIs where they feel like because of the way that their research has gone, or even their funding has gone, some scope needs to change. And that's when I have a conversation with them to determine if we feel like the scope has changed too much. And if it's changed too much, they might really need to submit a new proposal rather than a renewal based on their previous scope of research. All right, the basic agenda is I'm going to walk through some overview information. So what the allocation programs look like at the LCFs, primarily the details about INCITE, some recent statistics about INCITE to give you some scope, and what we're going to be allocating for the 2025 years. And then we'll move into some of the help we're getting from Kyle and Mitra today, talking about some tips and really just ways to think about the larger structure of the proposal and what those sections are. And then we'll move into some Q&A and just some final reminders at the end. There are not many changes to the proposal process this year compared to previous years. If you have done this before, we have adjusted a little bit. So we're asking everyone to submit a short paragraph in the PeerNet system that we use to collect proposals. So we're asking everyone to submit a short paragraph that we might use as a first draft for public use to share your information about your award, should you be awarded. There's a small, sort of change in sort of focus on the side of the program office, where we are trying to sort of elevate also data. So I ask people to pay attention to what kind of data they're going to generate or need to pull in and how long it needs to persist. But just be aware that you'll see in coming years, I think, a little bit more focus on that to make sure that projects paint a clear picture of their data requirements. That's not written here. I'm adding that in. And as in some previous years, there is proposal support. If you have questions and it is not during this webinar, there always has been. You can go directly to the INCITE Program Manager, me. You can go directly to your facilities, of course, always, right? And ask at OLCF or ALCF if you've got folks that you're working with there. But you can also go through the DOE Leadership Computing site and sort of ask some more explicit support should you want that. All right, some other quick changes are resource availability. So at the moment, Polaris is only going to be awarded for the 2025 year. So you will not be able to ask for 2 or 3 year awards on Polaris. Frontier is expected to be available completely for 3-year proposals, and the same with Aurora. We expect that to be fully open for 3-year proposals. At the LCFs, we break up the available compute time on these systems into 3 big buckets. The primary bucket is INCITE. This is really our flagship program. This is the program through which we deliver our mission as a leadership computing facility. So it is our primary program. That's 60% of the hours. 30% of the hours go to our sponsor in the Department of Energy. That's the Oscar office. And they award 30% through the Oscar Leadership Computing Challenge. That has different requirements than INCITE and has a little bit more mission-driven component that INCITE does not have. And then 10% is available for the directors. So 10% at ALCF and OLCF are available for the facilities to use strategically. The primary role for discretionary, especially in the context of this webinar today, is preparing proposals for INCITE or ALCF. So getting initial data, getting yourself on the system and making sure you can make use of it. There's other reasons we use that sort of strategic development of other resources and other capabilities, but that's the primary value here. I recommend everyone remember the discretionary program. And so finally getting a little bit to it, right? What is INCITE? And the reason INCITE was created was to promote transformational advances in science and technology through large systems that would otherwise not be available to the open science community. The premise is really to give researchers incredibly large allocations of compute time or data, even support resources that they would not be able to get at any other facility. And we're looking within this to really support as I said, these transformational, these really high impact problems that could not be done, or not be done at least in a timely manner, without access to the scale of resources we have available here. And I will say that, you know, INCITE is open to really kind of any type of project that needs large scale resources, whether it's compute intensive or data intensive, or other intensive. That is absolutely a valid reason to look to INCITE and potentially to compete. And we'll even get into some better questions to ask yourself whether it matches, whether your project might match INCITE or not. So for the most part, this is related to what I was saying, that what we're looking for is high impact research. Your domain is kind of, it's important to you, right? But we're looking for broad areas of research. We don't necessarily, you know, just have segments that we give so much to astro and so much to chemistry and so much to biology. We have a broad range of domains that have applied to do research through INCITE over the course of its more than 15-year history, and has done so very, very successfully. And this is just a small sampling of some of the domains that we see. We also see emerging domains, you know, areas of research that blossom up and might, you know, come back down, or we still are seeing some areas blossom up right now and sort of having a really large presence. So really, it's any area of science. There's no requirement about what domain or what type of research you're doing. And this is related to the criteria for INCITE, which is why I sort of led with that. The primary merit for a successful proposal is whether you have a research campaign with a potential for significant impact on your domain or on your community. Impact is broadly defined. This can be that you're answering a question your domain has been trying to ask for or answer for a very long time, but it can also be you're generating a tool that's really valuable, or you're generating a data set that people are really, really in need of. It's broad, and other impacts are included in that, right? It's not just, I'm not just listing the whole list there. So impact is broad, but it's really these kinds of things that you expect will have this impact on your research community. The second criteria is that you can't really do this work elsewhere. That might be because you need the computational abilities or the data capabilities or the right combination of these things. It might be that you're trying to push AI at scale, or you need specific aspects of the architecture at the facility. But fundamentally, you just would have a hard time or not even be able to do this at another site. And then the third criteria is kind of a non-criteria. You can apply regardless of your funding source. So you do not need to be getting Department of Energy money. You do not need to be Department of Energy mission aligned. Anyone may apply. And in the review process, there is no bias to who's funding who or what domain of research you are doing. In addition to that, non-US based researchers are welcome to apply. We consistently have non-US based researchers who are successful every year. This is not a US lockdown program. The review process is primarily focused on the peer review. There are two different things your proposal will go through, two different processes your proposal will go through, but the primary one is the science panel. And what we do here is try to collect experts in a shared area. So for example, it might be in astrophysics, right, where we have lots of supernova problems, lots of gravity-based and cosmology problems, things like this, right? We're collecting experts, and they are looking at the appropriateness of your project, the impact of the project, whether you have the right team to do this, whether you set out a trajectory that makes sense, right? Like, so whether they're convinced you can actually tackle this problem with what you've presented in terms of tools and in terms of milestones, and whether your request is reasonable. So one of the things we're asking the reviewers is what the impact of this work will be. And they do a comparison between, you know, what impact they feel, you know, they've gotten from your proposal and what they believe this might be for the community, but then also how reasonable the resource is aligned with that potential impact. And without a doubt, our peer panel definitely come back with suggestions sometimes where, maybe this is a good proposal, but maybe this is not enough time, or this is too much time to tackle this problem. And there's ways we manage that within the program. All new proposals also go through a technical assessment. And so what that means is we're just looking to make sure you are ready to run. While the peer panels, the science panels, are experts from around the world, from universities and industry and research labs, the technical assessment is run by and executed by the LCF centers. So Oak Ridge and ALCF experts read these proposals to make sure that we have confidence that they have done a reasonable estimate of time, to make sure that maybe understand whether the code has run on the appropriate facilities or not, and to make sure that generally what the risk is on a particular project. So are you ready to go day one? Like, you've got everything lined up, it's 100%, whether we might be waiting for data for your project to start, or whether, it's going to take some time because there's still some issues to work through. What you should understand is, for new proposals, the awards are almost entirely based on the science panel results. We're looking at the top meritorious proposals that come out of that panel. Secondly, we then look at the risk component from the technical assessment. So if, all the proposals are super high ranked, but they're super high risk, we make some other judgments and assessments there, because when we are awarding these resources, we're also awarding people. So we have scientific experts at both facilities who collaborate with any INCITE projects as much as the INCITE project would really wants, right? So we're making sure that we have the resources on board to actually help and make sure your project is successful. And so if we have a lot of projects that are high risk, that might go into the total balance of what we award in a particular year. For the renewals, as I mentioned, we're primarily focused on whether a project has stayed consistent with their original proposal and is making progress on their milestones. If you have not made progress on your milestones, then what we're looking to understand, and what the panel is looking to understand, is why have you not made progress? And sometimes there's completely understandable reasons why that is the case. But we really do want to understand where you are and why you are where you are with your proposal. And as I mentioned before, understand, that staying on scope is really quite important. Small iterations are not as crucial as, like, if you're introducing an entire new branch to your proposal in a renewal, that really calls up some questions. And I really strongly encourage you, if you're adding content to your proposal substantively, please talk to me before you go too far with that, before we even get too close to the new proposal deadline, just in case we feel like it's crossing a line where we might need to submit. Similarly, for the technical assessment on renewals, it's much like the other things I've mentioned. We're just making sure that you are on track with the technical milestones, because most proposals have aspects of developing new capabilities and testing them. And if you're not, we're trying to make sure we understand why not, if we don't already know. Hopefully, if you're a renewal, we already have a sense of where you are with your milestones. But if there are new things in there that are a surprise, we're trying to make sure that that is transparent and understood. The outcome of all of this process that happens over the summer goes to the awards committee for INCITE. The awards committee is the directors for each LCF, the INCITE program manager, and then the 2 directors of science for each LCF, and then along with various other senior management that we pull in to help us make these decisions. And as I mentioned, what we're primarily looking for here are those high merit projects. That is the primary mechanism by which we make the decision. There are a few limitations on what can be done on these systems, but they're very, very few. The first comment, right, is that we have cybersecurity plans, and that's the real limiter on what types of data that can be stored on the systems. So things that we cannot have are things like PII, classified information, national security information, unclassified controlled nuclear information, et cetera. And if you have, or you think you might have any of these, again, talk to me and let us work through that and make sure that you absolutely have to have it, or make sure that there's not some other mechanism we can have for you to successfully apply. I should also mention, actually, going back here, you know, there are some other, there's one other small limitation, which can be that there are some countries, the state sponsors for terrorism countries, that official list from the State Department, that we cannot get access to the systems. So for example, if your staff is primarily made up of folks from those countries, we need to have a conversation. Again, I would encourage you first to reach out and ask about this rather than walking away and going, oh, no, I can't do this. Let's figure out what the situation is in detail, because it's a complex system, and we can walk through that and make sure we have a correct answer for you. Now, there is some room for proprietary work within INCITE, and the reason this is even a slide, to make sure I articulate this a few times in this conversation, it's that INCITE is focused on open science research. So you as a researcher do not pay to get access to the leadership computing facilities. You do not pay for your INCITE time, even though its value is very, very high when you consider the cost of the systems and the people. But we expect that all work is published, right? So that eventually this goes back into the public through sharing that through publication. So we often get our questions from, especially industry, about proprietary work. And so there are mechanisms for an industry user or an industry group, a company, to do proprietary work where they might not eventually return this back to the public through publication. But this is, again, one of these complex situations that I encourage you to reach out and talk to me about. Often what we find we can do is find things that this project could publish that would not violate any industry sensitive information, but we just need to identify those and make sure that that might be the case, and that can make it much easier to work through the INCITE process. One other valuable piece of information about sort of what does work and doesn't work within INCITE is community versus umbrella proposals, and I will describe what that means. We encourage within INCITE community proposals, and this is when a community comes together and they agree on a course of action to tackle a particular problem. So you might have, a community proposal might be a proposal with a PI, but very substantial list of co-Is, but they are working on organizing themselves with some consensus on how to tackle a problem. Those proposals tend to be completely aligned with INCITE and work within our review process. A different type of proposal is an umbrella proposal, and this is one that we do not encourage. We don't ban them because there's no check mark, are you an umbrella or a community? And there's a subtle line here, but an umbrella proposal is one where instead of bringing researchers together and coming to a consensus on how to tackle perhaps a grand challenge problem, this is where there are multiple different problems that have been put together in order to make a proposal big enough to ask for INCITE. So you could imagine that if a proposal is asking for 1 million node hours, but there are 8 different completely disjoint problems within that proposal, it might have a hard time with each of those 8 competing for an INCITE proposal. So instead they bring them together to make it look like it has a larger need. The reason the umbrella proposals are discouraged is because it is very hard to review them. And the best way to understand this is an example, right? So we have had situations where umbrella proposals have come in and they might be they were tackling multiple problems, but there were other proposals within that panel that were tackling just alone that one problem that the umbrella proposal was tackling. So what our panelists were faced with was a situation where this problem, which was of interest to them, there was one proposal that had 15 pages of narrative and description for how they were going to tackle it, and another proposal that had that as a part of the proposal, but there's so much less space within 15 pages to tackle the details of that problem, they can't really do a fair comparison. So umbrella proposals inevitably kind of get downranked, right, because they can't do as deep of a comparison on that umbrella proposal because it's just too split up, it's too spread out between these different problems. So it's a subtle difference, but it's an important one. And I do encourage you to think carefully about this. And again, this is a great conversation. I normally have a conversation with a few PIs every year about, is this actually an umbrella? Does this count as that? Will I be harmed by this? It's easiest just to have a conversation about it and get some clear guidance, because we've had a lot of experience looking at these and understanding sort of what sets off what might be hard in the panel or not. All right. A few bit of statistics to give you some context for at least what we looked like last year and what we might look like going forward. So some statistics for 24 as we close the call on June 16th. At that time, we were awarding Frontier and Polaris, and Aurora was potentially in the pool. 1/4 of Aurora time was awarded. So that is projects that were awarded time on Aurora were given time, but told they might not get that time until very late in 2024. And they had to accept that limitation with the time. We had 108 proposals submitted. That's a relatively small number compared to, not the smallest we've ever had, but it is small historically. We normally see something more in the 130 range, 140 range. 75 projects of those 108 were awarded, 15 of which were renewals. I will say that acceptance rate is also higher than what you might normally see. And that's really driven by new resources coming on. So Frontier, it was not new last year, but was still an early system. And Aurora was, while not fully there, partially available. In these early years of a new system, especially that first 1 or 2 years, the awards tend to be higher in terms of total number of individual projects, as we're trying to get people on the system, get people to be able to use it and experiment and see what it can do. So that's part of what's going on here. And I expect, you might see this again next year with a slightly higher acceptance rate than not than 24, but than what we normally see historically. So while 65% of non-renewals were accepted last year, this rate's normally more like 30% when we hit more of a steady state. So it will start falling off into that closer to the next, in the next year or two. The other thing that's, I think, valuable here is to understand that, we do have PIs coming from a pretty broad range of areas. And this is a pretty consistent breakdown, like modulo, a few 10% here or there, which is that the bulk of our researchers do come from universities, so they're academic institutions. Then the second highest chunk is normally from government. Here means like national labs or research facilities. So that might be coming from NASA or other Department of Energy labs or the National Institutes of Health, et cetera. 14% last year were foreign, so PIs who were based in a non-US based institution, and then 7% from industry. Some other award statistics to break down that 75 awarded, and this gives you that sense that I was talking about before of what might be, these higher rates of acceptance moving into a newer system. There were 59 projects awarded on Frontier, 16 on Polaris, and 24 on Aurora, even with the 1/4. Of course, that does not sum up to 75. And the reason to make sure this is clear to everyone is that you can request time on multiple resources. And so you have a pretty broad breakdown about projects that ask for some balance, some linear combination of Frontier, Polaris, and Aurora. Another valuable piece of information out of this slide is what were average awards at that point, especially for Frontier and Polaris. So Frontier is looking at about 800,000 node hours as the average size of the award, and Polaris was at 156,000 for the average size of an award. Aurora is smaller, of course, because we were awarding 1/4, but it's going to be on par with Frontier in terms of the scale of awards that we will be awarding. And the reason this is valuable is so you know whether you're substantially lower than that number or way higher. If you're like 5 times higher than that average count, have a conversation with me or with whatever, with representatives from either facility that you're working at, you want to work at, that needs a conversation, because sometimes when projects come in that are super large, it's if a 5 million or 10 million node hour ask comes in, it's very hard to deal with that appropriately, because it's such a large ask and so much higher than what we might otherwise see. It's such a large fraction of the total system. But don't walk away. Again, just talk to us and sort of figure out some steps forward. We started a few years ago an early career program. The premise behind this is to give early career researchers a landing pad, right? So this is someplace for you to go if you're in your first 10 years out of your PhD. And fundamentally, it is a potential boost in the likelihood of you getting an award, because what we do is we don't review these proposals any differently. They go through the exact same review process. We ask even the peer panels, don't, elevate an early career proposal, put it where you think it belongs in terms of comparison and merit against the rest of your panel. But when we are going through the award process, we are looking to understand, what's our balance here? Do we have early career representation? And so we might dig a little bit deeper in order to elevate an early career proposal. So last year, we awarded 17 early career awards, and and these were all for new proposals. So there were 33 total early career applicants out of 97. Pardon me. The other thing to touch on, as I mentioned a few times, are what the science panels look like. So in 24, we had 95 science experts. These are diverse panels. They cover a wide variety of areas, and even within a particular panel, it might cover some pretty broad approaches to how to tackle problems in a domain. So we have an astrophysics panel. We have two materials panels kind of focused on two different types of methods. Last year, we had a huge amount of biology proposals, and we split there. Fundamentally, it was sort of biophysics in one group, really focused on, if you had a molecule or protein or something of interest, versus more biomedicine-like things. That was the split. But we have a really broad range of reviewers, from very credentialed, very, frankly, prestigious folks coming in to both review and to chair our panels. We do promote carryover from one year to another, so we have some continuity within the panels. We also like to bring in new blood and new perspectives, but we also find that having some memory within a panel is pretty important. The other aspect of the science panels that's worth noting is we have had a panel focused on learning technologies for several years now. When appropriate, if there is a domain proposal that has a very large data or learning component, we will have that also read within the learning panel. And the primary reason there is to figure out, maybe there's something innovative within the learning technologies in this proposal that the learning panel might want to elevate and point out. But it's again, to make sure we're sort of making a proper assessment of the proposals. We do generally have large representation of folks who are domain experts who also are using learning techniques and are experts within all of the domain panels. Right. I talked a bit on the early career path, but as I mentioned, this is sort of a landing pad. So we commit up to 10% of the allocatable hours for early career folks. So I do encourage you, if you're in your first 10 years, there's no harm in checkboxing. The only requirement that's not listed here is if you have been a previous PI. So the premise here is to really encourage people to come in and to increase that pool of young researchers. So if you have been a previous PI, that does make you not eligible to apply again through the early career. We will have 3 resources available for request in 2025. So that's Frontier at OLCF, Polaris at ALCF, and Aurora at ALCF. And my comrades in arms here will walk through details about these systems, but also some other aspects of the proposal writing process. But I remind you that Polaris is the one machine that we will not be doing multi-year awards on for 2025. Beyond 2025. So you can only ask for 1 year. Then before we switch and you get to hear a different voice for a few minutes, I wanted to touch on how you can estimate time on the LCF resources. In part, this slide has been in the past couple of years. We always have a flavor of this as new machines are hitting the floor, but the primary way for you to do your estimates on the amount of time you will need to execute your project is to get on Polaris and to get on Frontier and to try to run your code of interest, and really get a proper sense at that point, how your code is running and how much data you will need. This is why the discretionary program exists. It's very low. It's very low bar for entry. It's very quick. It's a few paragraphs that you have to write. You should be able to get access very quickly in a couple weeks. And at that point, you will have what you need to be able to do some basic scaling and timing, etc. Now, Aurora is not available. And so since it is not available for the public, I should say, we do give some guidance here so that you can make an estimate for what you will need. The primary thing I will say here is that if you are doing a projection, as you will need to unless you are early science or an exascale computing project, just tell us how you're doing that calculation. And we understand you don't have access. We're not going to penalize you for that. We just want to know that, okay, based on timings, say, for example, from Frontier or from Polaris, these are my estimates for Aurora. And you can use this with other systems, but the benefit to using using Frontier or Polaris right now is that, you'll sort of be within the LCF system where there is a little bit more consistency. All right, and these are just some conversion factors. So for example, if you're going from Frontier to Aurora, think maybe just 1-to-1. We're not making a statement about the actual performance of the node hours from one to another, but this is just the easy back of the hand. If everybody does this, then this is easy for us to understand. They have said that they're converting from Frontier and they're using this 1-to-1 versus for Polaris, you can do a 2-to-1 from Polaris to Aurora. It should be noted before I click too fast that when you ask and when you make a request in your proposal for, time on, say, Polaris and Frontier, those hours are not easily transferable. And this is something that sometimes people don't really quite understand. Once we make the awards, it's very hard to sort of say, okay, they now actually really want a big chunk of Aurora time. That's tricky. So we ask you to do your best in planning in advance. I do see a question here, which is, would an early career proposal be welcomed from a PI in private industry? Absolutely. Absolutely. There's no requirement that you are in a academic institution, for example, working towards a professorhood or something. Absolutely. If you are in your first 10 years, please, you're in industry, you may absolutely be a candidate in an early career. All right, with that, I will hand off to Dimitri. Hi, there he is.
Hello, sound check.
Yes.
All right, thanks, Katherine. So we'll start discussing resources at OLCF. And as Katherine already mentioned, we will be allocating time on the Frontier machine. So we are very proud of that machine. It's our exascale computing, our flagship. It contains the AMD hardware, which was integrated and built by HP Cray into a Frontier supercomputer. So its peak performance is more than 1.5 exaflop. It contains the AMD EPIC CPUs and the MI 250X GPUs. We have 4 GPU devices per node, which is actually each of those has 2 GCDs, so basically 8. You can run up to 8 MPI processors on each GCD. So the memory per node is 512 GB, and you have 64 GB on the GPU side. The total node count is 9408. The interconnect is also coming from AMD. It's Infinite Fabric with coherent memory access. The interconnect is Slingshot with the speeds of up to 100 GB per second. And the Slingshot Dragonfly, that is the topology of that network. We have the storage attached to that machine, which is 679 petabytes GPFS type of storage. So that is our machine. It's entering the 3rd year of production runs. It's pretty established. Obviously, we have the developed software stack from HP and Cray, and as well as AMD. There are 2 links down at that slide. You can follow and learn more about the machine. If you have something more exotic in terms of software, let us know. Obviously we have all the libraries, tools, compilers, everything you would need, but if you have something more exotic, yeah, just follow that link and let us know. Most likely we'll accommodate your request. So that is Frontier at OLCF. And then Kyle will talk about ALCF resources.
Thanks, Dyma. I'll talk about the two machines that we have available for INCITE allocations in the next year, and then we'll be going down to one, as mentioned before. So Polaris is currently our main production machine until Aurora gets out of its pre-production phase. It's on the smaller side at only 44 petaflops of double precision. That's if you also use the tensor cores on the 4 A100s to their full capabilities. 4 A100s per node, that is. Like I said, it's slightly smaller. It's only 560 nodes and only available for 1 year, but it could be a good candidate for a targeted allocation if your project is only has 1 year in scope, or perhaps you're going to use it as a stepping stone to a larger year 2 or year 3 allocation on Aurora and or Frontier. Although it's nice about all these machines is they're all integrated by HPE and they all have Slingshot 11 for the interconnect fabric. And that's really why Polaris was acquired, is to be the stepping stone from people who may have only run on the CPU machines that were common at the ALCF in the past and are now moving to GPU machines, albeit different vendor GPUs. We actually just upgraded the hardware and the software stack on Polaris, so it has some close parity with Perlmutter at NERSC for those who have used that. We're now on a CUDA 12.2 driver. And the software that's available on there is meant to overlap a lot with the software available on Aurora in order to be a good stepping stone. Next slide, please. So here's a list of all the common programming models, tools, machine learning frameworks, languages that are supported on Polaris. And like I said, it's meant to have a good overlap and be a stepping stone to Aurora, because these programming models that you see in the bottom left are all supported for performance portability across AMD, NVIDIA, and Intel GPUs. Being a NVIDIA machine, we do of course have CUDA and the NVIDIA HPC SDK, which is a bit newer, but because we want people to prepare for Aurora, SYCL and Data Parallel C++ are given a point of emphasis and a lot of attention from the software support folks at Argonne and at Intel as well. You have all your standard performance profiling and debugging tools, and every 6 months or so we will put out a new community version of an Anaconda module that has the latest TensorFlow, PyTorch, DDP, Horovod, Spark, basically anything you could want for a machine learning component to your application. Next slide. But this is all leading up to Aurora, which, as Katherine's mentioned, is in pre-production phase right now. It's not available to the public, but it will be available for allocation starting the first of the next year. So Aurora is going to be on the scale of Frontier, around 10,000 nodes, and it's going to have it has 6 Intel GPUs per node. Kind of like the MI250Xs, these can be considered 12 devices because they each have 2 tiles. And it has the same HP Slingshot 11 topology with Dragonfly topology that is available on Frontier. What's really unique about the system is the storage file system, and it's what have a lot of people very excited to use the machine because it has a lot of injection and bisection bandwidth. And it's an object store, so it doesn't have just a POSIX interface, but it has object store semantics and plugins for HDF5 and other storage libraries that can really get storage I/O bound applications a big boost in performance. Next slide. So I won't repeat all the libraries and tools and programming models and frameworks that were listed here, because again, there's a huge overlap with the Polaris ones. I mean, the big change is going to be the omission, of course, of CUDA. So if your code is written only for NVIDIA GPUs, you're going to have to change things, and it'll be a big part of your technical assessment to show that if you want to use time on Aurora, that you have a way to get away from the CUDA dependency. Next slide. So now that we've covered the resources that are available for allocation requests, we'll focus on talking about how to construct a successful narrative to maximize your chances of actually getting awarded. So to start, before you even sit down to write your proposal, we put out these questions that you want to ask yourself that you can write down the answers to. They might not all be relevant to your proposal, but you should consider all of them, even if it's just a quick yes or no. Because surely the technical assessors, the first phase of the review process, will be thinking about all of these questions. And if you haven't answered these questions yourself, it'll be something easily identifiable to a technical assessor that might ding your possibilities for getting an award. And also the peer-reviewed science panels will be thinking about them too. So the first one that's most important is both the scale of the runs and the time demands at the leadership class facility scale. Now, there are a lot of applications that, if you really think hard about it, you can accomplish the same goals on a university-sized cluster if you just had additional time or had to contend with the other users on the machine. So if you can consider that the unique hardware and architectural features of Aurora, or say like the storage system, or Frontier like the interconnect, make it so that your science can only be done on these machines. And in addition to the interconnect and the storage system, there might be architectural features such as the mixed precision support on the GPUs, or and other I/O characteristics like NVMe local storage that your algorithm will not run in a performant way unless it has access to those resources that certainly aren't available in all university clusters. The third question I'd ask, and one that's often neglected, is do you actually have the personnel committed to using the time on the LCF machines if you're awarded the time? Because you might have several co-PIs that have not super determined time to devote to get running these jobs. If they're not embedded in the facility, like it is a significant effort to scale up sometimes from your local Slurm cluster where perhaps you only have a couple hundred nodes to 10,000 nodes. Not only do you have to translate the scheduling, the job submission scheduler, and contend with these very unique features like the I/O system and deal with the Lusser system and move all the data that you need onto the machines, compile and deal with the various errors that you might encounter, but you'll have support from the LCF folks, the catalysts at ALCF and the liaisons at OLCF if you have time at either of those facilities, but you still need some folks that are on the proposal, whether that's a PI, a postdoc, a grad student, who are going to devote this sufficient time to use the node hours and not waste them. Because once the year goes by, if those node hours are not fungible, you can't just roll them over the next year if you have a multi-year proposal, as Katherine said. You can't shuffle them between systems and certainly between facilities. Next slide. So these questions are more, don't apply to every proposal. If you have a traditional, just say you're doing a few large PDE simulations, certainly there might not be an AI component, there might not be a visualization component or a workflow solution. Your workflow might just be compile your monolithic code and run it a couple times. But we see the evolution in the past few years, increasing use of machine learning, increasing use of complicated workflows, visualization, several different code components running asynchronously. And if you have a proposal like this, you need to think about all of these questions. So if you have large data and AI needs, it isn't as simple to run TensorFlow or PyTorch oftentimes as it is on a smaller DGX machine or on a laptop. And so you have to think about how AI is run at the national labs on these resources. For the most part, there are a lot of turnkey solutions, but once you get into scaling, let's say training a neural network up to hundreds of nodes, the scaling behavior can be quite different. And so this is something that a technical assessor or reviewer is going to be looking for. Similarly, workflow solutions, when you have these complicated I/O systems where your files may be hundreds of terabytes and be striped across a Lustre file system, you have to come up with a solution if you're plugging in different asynchronous codes in order to have them all work together to get to your ultimate solution. If you're going to tie these together into a job submission scheduler, you have to have thought about the workflow tools you'll use, such as Parcel and Balsam are very popular tools at the ALCF in particular. And so it'll be good to at least mention these in your proposal to show that you've thought about how to tie all these pieces together in a way that isn't just a machine that you have dedicated 100% access to. In a similar vein, the post-processing strategy, once you've created perhaps hundreds of terabytes of outputs, you need to come up with a way or plan to ingest them and get scientific outputs and not just leave them on disk or tape for long-term time. So that might involve another complicated piece of software that may or may not be already supported at the LCF that you should check and re-reference those earlier slides for the available tools and software to make sure that the post-processing strategy is going to be viable for your application. Ensembles are becoming also more popular. This has been kind of tied into the large data AI point earlier. There'll be another slide on this further, but ensembles are a bit complex because we see a whole spectrum of them, where from the embarrassingly parallel ensembles where feasibly you could run the same type of code millions or billions of times on, say, a laptop, and then just do some bulk statistics computation at the very end. In this case, it would be unlikely to be a good candidate for an INCITE award because there's nothing really unique about Aurora or Frontier that would be necessary for your problem. And also, as a point of emphasis for applications this year is thinking about those outputs and inputs that you have for your INCITE project. Is not all data that's going to be produced by your codes going to be of equal value for equally long time. And so if you really break it down into the things that you need to keep for, say, a 6-month time horizon and multi-year, it'll be great to think about this before you sit down to write the proposal, because then you can write down your milestones in a much clearer and well elucidated fashion that'll be appreciated by the technical assessors. So we'll go through the outline on the proposal here. I would encourage you to go to the INCITE website, doeleadershipcomputing.com, where we have templates which are in this exact structure that'll be helpful for you when you actually sit down to write the proposal after answering those earlier questions in an outline. And I'll note that as someone who's been on the technical assessment committee, we do look at every part of this narrative. Of course, the summary and the main narrative, but the personnel justification, as I said, is something that's often not given too much attention by the submission, and the milestone table is going to be tied to the specifics of the machine, so we really value that. Next slide. If you take anything away from my section of this webinar, I would say that you need to know your audience if you want to have a good shot at getting an INCITE allocation. And that's somewhat generic sounding because whenever you write a proposal, you need to know your audience. But the INCITE committees are very unique, as Katherine discussed. And so the reviewers are very broad in scope. Take, for instance, the astrophysics panel. It might have someone who's an expert in planetary dynamics, stellar dynamics, cosmologists, experimentalists that look at big data coming from telescopes. You have all these different types of folks that pulled from academia, industry, government, that are in your field but may not be super familiar with your particular subfield of your application. And so you really need to drive home the importance of your proposal, the scientific impact to your subfield, and not just assume that the reviewers know why this is an important computational problem that merits very valuable time on these computers. They're also, as mentioned, many of them come from many years of service on these panels, and so they know perhaps what the earlier proposals that were awarded or denied in previous years from your particular subfield, what those impacts were and how well and successful they were, so they can put yours into that context, even if they're not, super proficient from your subfield. And so do look at the resources we have on the website, which shows the questionnaires that we give these reviewers every year, which can help you think about how they will think about your proposal when it comes before them. They'll also be really familiar with alternative compute time allocation programs, such as from the NSF. And so they'll also ask the question is, okay, maybe your proposal is not a very good fit for INCITE, but it's actually a better fit for NSF. So they'll be thinking about all these questions. Next slide. And the prima facie thing when you're writing the proposal is the impact of the work. If you don't have a grand computational impact that is likely to lead to big scientific insights, then the other parts of the proposal won't matter. This is going to be, it might not be, this is going back to the previous slide, why they might not be familiar with your subfield, but this is your job to show what the current state is of the computational results from your subfield and what the next big step is and why your proposal is the one that's going to achieve it or is likely to achieve it. So this big picture is going to be the most important factor in determining whether or not you're going to be granted your award. And these machines, are only around for a few years for when they're actually at the cutting edge of computational science. And so it needs to be a timely request too, that this is the most important problem right now, and it can't be something that, may be more appropriate to look at in a few years in the future, or would have been actually cutting edge years ago. And so that's something that the reviewers are charged with, and they have to think about the timeliness of your proposal as well. Next slide. So once you have this grand narrative that really centers around the grand scientific impact that's tailored to your audience of the reviewers in your overall field, then you want to drill down into the tangible steps you'll take to get to that grand objective. So you'll want to break down into the computational steps and intermediate pathway that you're going to take to get to the overall objective. So this is the milestone table that I mentioned in the project narrative is going to be the core of this. And you'll fill out a few parts of the table of what will be the node hours you'll expect to use for each part of the milestones. And then once you're in the narrative, you'll want to go into further detail about the types of simulations, analysis, and computational, perhaps development of new parts of the algorithm that are going to be essential to each of those milestones. And although it's important to keep in mind that even though there's no monetary award for personnel that's associated with an INCITE award, the computational time here, if you valued it on the street, be worth oftentimes millions of dollars. And so these milestones are really important to the reviewers because they want to make sure that there's not some risk of you wasting them or going the wrong path. You don't have some intermediate result that increases the likelihood of your success. It's also important to have these milestones because in the case in which the reviewers, they only have so many node hours in the allocation committee to give to INCITE projects, if they have to give you a reduced award, they can look at your milestones and say, okay, we believe that this component of your proposal is the most important part, so we'll award the time for that, but we will cut out this other milestone that we don't think we can afford to give you time this year, but perhaps in future years. Next slide. So once you have the milestones, and I said you go into the narrative of actually drilling down to the computational details, this is where really the technical assessment comes in to become important. You'll want to describe the algorithms and the actual codes that'll be the foundation of your proposal. Again, with the reviewers, the same comment with the reviewers, you can't assume that they're going to know the names of your codes, especially if it's some forked private code that you only use in your lab that you'd have to read, be very familiar with the literature for. So you want to go into some depth to describe the history of the codes, the library dependencies that they're built upon, and the programming languages, especially cross-referencing them to the earlier slides of the software libraries, programming languages that are supported currently on Polaris, Aurora, Frontier, whichever one you're proposing to get time on. And if you find that some library that your code depends on is not listed there, it'd be important to discuss a strategy for building it on Polaris, say, for example. Maybe you've already worked with folks at the ALCF and you've already built a private version of this essential library. If not, it's important to give a strategy of how you do it. But if you say, oh, I'm going to build CUDA on Aurora, of course, that'll be an obvious red flag to the technical assessors that will make it unlikely for you to get time awarded because it shows that you haven't thought about how to actually use your codes on a machine that wouldn't support the underlying libraries. Next slide. Similarly, the data management point of emphasis. If you are an AI or a big data project, you'll know that you have to stage in perhaps hundreds of terabytes of data, and you would be very inefficient to use this over SCP or SFTP, for example. And so you want to at least include a few paragraphs about your strategy for bringing data in and out from the LCFs from maybe your university or whatever private storage, as well as whatever storage allocation you're requesting, how you're going to consume it over time. This is especially important between disk and tape usage, although the policies at OLCF is changing a bit for this. The ALCF has a tape system, of course, that a lot of your data, if it's not going to be touched for a while, can sit safely on tape, and you can save some of your, you can decrease your disk request if you only need a certain amount in flight at a given time. So things like Globus would often be described as a useful tool for bringing in data, but you might have some alternative way to ship in the data, especially if there's privacy concerns. It's something you want to talk to Katherine about. So then similarly in the data and AI workflows, I think I've already mentioned this, but the workflow tools are becoming really kind of first-class components of a lot of these proposals, especially when you combine simulation and machine learning. And if anyone who's used those types of, done those types of projects know that you can't just, run them simply and then, transfer things on disk through bash tools. There's actually sophisticated first-class members of your proposal, software members that will be essential to being the glue to tie these tools together. Next slide. This is just another emphasis on how you're going to write your milestones. When you request, say, 1 million node hours on a given machine, we want to see how you came to that number. And when you tie them to the milestones and the specifics of the machine, you're going to want to break down how you got to that number. So you're going to take, say, perhaps oftentimes you find like the earlier milestones are more exploratory in nature, and they might be smaller simulations, maybe say only a couple hundred nodes, but you're going to be doing lots of these types of runs. And so this perhaps might be your first quarter milestone is to do, 1,000 runs at 100 node size on Polaris. And this then is one chunk of your allocation. And then perhaps later in the year, you're going to do the big run on Aurora or Frontier. And this will, if you break it down like this and actually quantify it in the text, then you see the number in the table. It's easy for the technical assessor to look at that and show that you've reasoned about the specific sub-steps to get to your overall goal, and that the node hour request makes sense and isn't just a pool that you're, black box pool of node hours you're requesting. And you also, it's important when you have these different types of simulations or, machine learning campaigns, that the performance characteristics are going to be different depending on how large the actual jobs are. And so if you discuss the performance challenges, the IO challenges for the exploratory runs, and then another section for the big runs or the analysis runs, that will even help your case more. Next slide. And finally, once you've shown that you have the codes in place and the libraries in place, and you've thought about the sub-steps you're going to take in the overall pursuit of your objectives, you'll need to show that you can use the time efficiently. These will be something a lot of you are familiar with, how to show this, and you've showed this in many proposals and papers before. But another point that bears repeating is that you'll want to run similar problems on similar GPUs to what you'll actually be requesting. You may not be able to get obviously to 10,000 nodes, but you want to get as much as you can, and note that in the proposal that was your goal when you give a, say, scaling plot, that you used all the machine you had access to, or excuse me, you had a director's discretionary allocation that let you use up to 400 nodes on Polaris. Would be very, very useful. Gives as many specifics as you can, because as these technical assessors and reviewers are going to be very computationally proficient, they're going to ask about the threading, the distribution, and the affinity of the MPI ranks. And definitely include IO and don't turn it off inside of synthetic benchmarks. Make it very realistic to what you'll actually be running once again. And when you do scaling plots, we do want to see single node or single device actual throughput or other figure of merit specifics, because as any first-year HPC student knows one way to make your scaling look very good is to slow down your serial case. We won't accuse anyone of that, but it's useful for the technical assessors to know, can you even use a single device efficiently, or is it quite inefficient but good at scaling? Next slide. Everyone's seen scaling plots before. We just want to emphasize that we're not going to be very picky about the format they're given in. The more specifics, the better, as mentioned. But the y-axis can be anything that makes sense. It could be time to solution, or it could be a normalized figure of merit that's per rank or per device. And overall, you want to show, of course, that as you increase the problem size, as you're increasing the resources, that figure of merit, or that normalized figure of merit, or that time to solution remains flat for weak scaling. And then for strong scaling, that you'll want to show a linear decrease in the time to solution as you linearly increase the resources. AI, we'll mention, you don't have to be held to this kind of older format of scaling plots that have been around for decades. We've seen with AI developments such as in chinchilla papers, there's other ways to show utilization of the data set and the efficient use of flops. So those will also be accepted. We're not going to hold you to the specific format. Next slide. And one final note about the ensemble policy. You can consult the website and the frequently asked questions for more detail on this. As I mentioned, you really need to think about what makes your ensemble unique, whether that's a workflow tool that ties together the results or ingests the results of these ensembles. Maybe you spawn new ensemble jobs in a dynamic fashion, or that's something that comes out of simulation that really could not be done on a cluster, or could be done only very inefficiently on a smaller machine. And if you have any questions about this, whether or not your ensemble proposal is something that's a good fit for an INCITE program, you should reach out, and we can consider the specifics of your actual proposal before you embark on writing it. Okay, I think that's the last from my section. Back to Dyma.
Thanks, Kyle. Okay, we continue discussing the narrative. And the first thing I would like to touch is about data and AI applications. Obviously, as Kyle mentioned, we are welcoming AI-centered proposals, and obviously it should be clear that the AI aspects are very strong. And there are just few example areas we have here. It's like machine learning, deep learning, obviously, data-intensive computing, experimental, observational, simulational, data analytics, complex and interactive workflows, streaming real-time data, statistics, graphs, uncertainty quantification, these kind of examples. So on the next slide. So if you're doing one of those, like a project centered around one of those topics, what would make your proposal successful? Obviously, you need to clearly articulate the objectives and dependencies of the end-to-end research campaign, which mean like training data requirements, where it was generated, the actual model, how it was selected and validated for your deep learning or data-driven learning, and also model embedding to augment simulations and all kinds of other details. So the more details, the better. So also please list the application requirements, including databases, machine learning data learning frameworks, workflow software if you have one, and containers you're using. Again, please be specific. Yeah, it's just not enough to say like, hey, I'm running some TensorFlows and everything works on my side. So, and please demonstrate that the software can run efficiently on the resources requested. So obviously any combination of AI and converging AI with traditional mod sims are welcome. So we are not like putting things in two buckets, either AI or mod sim. AI is now very popular, and everybody's trying to do some kind of data processing on top of their modeling and simulations. But if it's even pure AI proposal, yes, please go ahead and submit and make clear that you touch on the points I'm highlighting here. Okay, next one. Okay, for all projects, you need to clearly state what kind of data usage strategy you have. So first of all, list your total online and offline storage for the project. And for each milestone, list the total online and offline storage, including the estimated duration of that data to be used. So for large data project, include a discussion of the data requirements. So what kind of, again, storage, duration of the storage, and what kind of formats you're using to store your data, retrieval, and so on. So if you have any special or unusual requirements, yeah, you need to put that in the proposal. Be specific, and make sure you read and you familiarize yourself with the center's data policies which exist, and you can follow the link to the either facility and read those. Okay, next one. Now we'll discuss the development work. So as part of the narrative or as part of your project, it is totally fine to have a development component. If you do have a development component, so for example, your code is being developed and the new functionality is coming, yeah? So if you have something like that, then please describe any additional development required to execute any of your milestones. So if your milestones depend on that development, highlight that. Identify those dependencies, highlight them, and also let us know how you would validate. So also estimate the computational resources required for this work. Yeah, so development work is not free. You will also use some cycles on those machines to actually do that developments. So please put that estimation as well. Okay, next one. Another integral part of your proposal is a management plan. What it needs to highlight is basically it is there to show the experience and the credibility of your team. So please list all the scientists and technical members and also their expertise and how they relate to actual goals which were set in your proposal. And successful proposal teams demonstrate a clear understanding of obviously HPC resources and how they can optimally use those. Again, specifically to achieve those goals you state. So what is important, then team members can be part of different proposals. Yeah, that's fine. Not the PIs, but the team members are fine. And also in the management plan explain the transparent use of time. So project, especially if it's a larger project involving multiple co-PIs, like how is the time actually spread between different milestones and different co-PIs. Also do include personal justification. That's a brief description of the role of each team member. And although it's not required, the proposal with application developers are usually viewed as a strong benefit, especially for the technical assessment. Okay, next one. Okay, management plan and now milestone table. Again, that is the other integral component of your narrative, of your application. So please do put a milestone table in your application, and there clearly state the scientific and technical milestones for each year of your proposed work. They should be appropriate. The milestone should be appropriate for the size and duration of the award you are seeking, and future modification will obviously be tracked using the milestone table. So what kind of details you need to put in the milestone table? So computing resources and allocation requested, obviously node hours, which machine, how much node hours, how many node hours, then production size of the runs, then file system, archival storage, duration, we talked about that. So what kind of software you're using, and summary of the computational task is that runs, pre-runs, data analysis, pre-processing, post-processing, what kind of dependencies you have, if you do have dependencies between milestones, and of course the date, expected starting date, target date, and all kinds of status, like where are you standing. Again, like milestone table is a required document. If you are not putting one in your narrative, you may be dismissed. Your proposal won't be accepted. Okay, next slide. Yeah, now we're talking a little bit more general. INCITE publications. So when you submit your INCITE application, please list publications resulted from previous INCITE. Obviously, the same like the academia, it is important part for us to track those publications and report back to DOE what kind of science we enable through our facilities. So it is important for you to give us that information. But please do include papers coming from the INCITE allocation, not just all papers. All right, so I think we're good here. Next one. So here's just a graphical timeline. Katherine already were mentioning what is the timeline, but graphically you can say, like, in the beginning of the proposal, we'll prepare for the call, we will open the call usually around April. The deadline is usually around mid-July this year. All the dates are shifting a little bit, so that's why always check with DOE leadershipcomputing.org what is the exact deadline. This year is June 14th. Please keep that in mind. So after you submitted, the technical assessment starts in June, July, August. Then the science panels will be assembled, and the science review is coming usually late summer, beginning of September. Decisions are usually made in October, and then awards are going to be announced right before scientific computing conferences, which is usually in beginning of November. Then you have a little bit of time to set up actually the projects. So for you can start January 1st with running your simulations. All right, the timeline. Next one. I guess at this point you hopefully you have a very good overview from me and Kyle and Katherine, like what is the INCITE, how to write your proposal, and you may ask yourself, like, am I ready? Yes. So to answer that, maybe think like, have you ported your code? So is it code ready to run? Maybe if you're not a developer of your code, just look around. Somebody from the community or somebody from OLCFs or from OLCF or ALCF, maybe they worked already with that code, and that's available. That happens quite often. So if you do have a code, so do you have experience? Do you have the compelling benchmark data? Did you run the scaling plots, or did you run the runs to assemble scaling plots? Did you run something which is actually a good representation of the proposed work? If you cannot show that, then obviously you may have problems with technical assessment. But if you have maybe access to some other GPU machines, you can still write a solid story. Just highlight what exactly you've been doing, like what's your plan for development, what's the mitigation strategy, and so on. Again, like as Katherine mentioned multiple times, science is the most important. The technicalities is just for us to have a good understanding where you're standing, but it's not a dismissing factor. Again, the benchmark example should be very close to what you actually propose for your science campaign. Okay, next one. Hopefully you answer that question. If am I ready, you answer yes, and if it's yes, go ahead and apply. If you do not have those numbers for your scaling plots, you can apply for the DD program first. The DD is kind of a foot in the door. It's a small allocation, but it can give you like exploratory type of access. So you can run, you can familiarize yourself with the machine. You can run some scaling data. You can port or tune your code, and usually you have a couple of months for that type of work. So if you are going to apply this year, then you have to apply for DD. If you do not have one, basically now, basically today. There are like links for each LCF. You can just follow the link. Applying for DD is very simple. It's just an online form. You just explain a little bit like what you're doing, what kind of codes, and it's a low bar. Obviously, we are very welcome people to apply and get themselves familiar. So that's final check. What if you have all the components in your narrative? So obviously you need to have the executive summary. That's just one page, and then the bulk is the project narrative. So impact of work, objectives, benchmarking, all of that goes into these 15 pages. Then personal justification management plan, we discussed that, milestone table, publication resulting from previous INCITE awards, and then the PI and co-PI bio sketches. So pretty straightforward, but just don't forget any of those components, and that should be fine. The next one. Yeah, basically we're done with discussing the narrative and highlighting the points you would like to stress while you're writing your application. Now we are in the, Katherine will provide you with a little bit more information on INCITE, and then we'll just transition to the question and answers. Thank you.
Thank you. Yeah, and we do want to pause, right? Because it's quite a long list of data of stuff that we give to you. So if there were questions right now, but I have a little bit of just, wrap up information. And of course we can take questions at the end as well. So I just wanted to give folks a moment to breathe and formulate. All right. I won't wait too long, especially because, as I said, if you have questions, I will answer them, live as we go through. And of course, when I have the last few slides done, we will tackle that then. So submitting your proposal or your renewal, you need to have access to the PeerNet system. So this is all linked from DOEleadershipcomputing.org, to start a proposal. But the PeerNet site is where you will put your proposal. There are two phases of sort of just some preliminary information entered directly into PeerNet, but then followed by uploading the documents themselves for the proposal. What I want people to understand is that you can save that proposal at any time. You do not have to, start it and finish it all in one go. You can save and go back to it. You can even submit it early, and before the call, you can go back and edit it, even if you have submitted it. So before the call closes. So anytime before the end of the day on June 14th, you can go back in and make adjustments. So submitting early doesn't really harm you in any way. It might save you from, if you're having issues hitting that submit button on the evening of. So just so you know, you don't even need special help in order to re-access your submitted proposal. It will just be there for you to edit when you log in. But it will require you to fill in sort of all the PeerNet materials before you move forward. So it's kind of sort of standard web forms, right? You need to do the required stuff, but in terms of uploading or changing information, you can do that at a later point. As I mentioned earlier, the award decisions are made with a award committee based with the awards committee is the directors for each LCF, the directors of science for each LCF, and the program manager for INCITE. And then, as mentioned, pulling in some of the senior staffs that we have at the facility to help make those decisions. We are really looking at those top ranked proposals out of our science panels. That is the top thing we are looking at. And then additional considerations that might go into this are things like a balanced portfolio or promoting use of these resources by underrepresented communities. And that can be a broad definition of community. It can be a new emerging area of research that we want to support. It can be a wide variety of things. But the primary thing is we're looking for meritorious proposals out of that panel. And then we do all of these other considerations of some balance of portfolio and some balance of making sure that we have the right staff to support you, etc. And as I also, just to repeat this, as I mentioned before, what we're really doing with the technical assessment, previously known as the computational readiness review, is to identify whether those highly ranked proposals are ready to go and how much human time we might want to commit to making sure that proposal is successful. And something that happens often is we see a very meritorious proposal, but that has no readiness. We see a few of these every year, and that there's often paths that we take with those proposals that are slightly different. As I mentioned, we're really working on sort of striking some balance. We have no quota for areas of research or quota for funding sources for anything. For any other proposals or how we make our portfolio, but we just, there's some reality that a balanced portfolio is more effective and in our requirements and communication. So that is the primary thing we look to have that balance. We're also looking to strike a balance on the individual proposals. So our goal, if your proposal is found to be highly meritorious, and we are trying to award the time, our goal is to award the time that your proposal is asking. There are times where peer panels come back and say, this part of a proposal is incredibly good. We really want this part done. This part has issues and we don't want this funded. It would be problematic. And so we find out from them, if we just fund this one part of the proposal, how highly would you rank it? And if we fund you, we'll tell you, we've awarded you for this part of your proposal and not another. That's the primary way by which large cuts to a proposal are made. Otherwise, you might see some small amount of shaving as we're trying to make sure we fit people in. The other thing to consider, though, is this goes back to that table I showed earlier about average award sizes. The biggest problem we run into is when a proposal is very large, much higher, much higher than an average award size. 2x is one thing, 5x might be another, and we don't have really good information from within the proposal, even how we could help by reducing the amount of time. Because as I mentioned, we need to have some balance of a portfolio. So we are looking for a small number of high impact proposals, but we also know from history, right, that if we're choosing, one proposal that basically, is taking up an incredibly large fraction, it's taking up like a third of the time we have available or a quarter of the time available, that risk is hard for us. So we're often looking, if it's too large, and we want to award some, it's great to have within your proposal some guidance on how we might actually reduce that size. Finally, you can submit an appeal after the decisions are announced if an error has occurred in the process, or sort of like a clerical error, like we lost your proposal somehow, or we really had wrong information somewhere along the line, even though you submitted the correct information. It is possible an award might be granted, but we cannot commit to that. We do not consider appeals based on the scientific merit of review. Without a doubt, I definitely hear from PIs every year, with criticism of their review. And I take that into consideration when we're building those panels again in the future years, but we just cannot do an appeal based on the science merit. As mentioned, we will announce the awards in early November. You will receive an email from me with an award decision. And then if you did not get an award, you will receive a follow-up after those go out with a declination information. At the point where you receive an award, you will start a sequence of things, right, to get access to the facility and to get your project set up. The sooner you start this, the easier it is. So I highly recommend you start it as soon as you have the reach out from the facilities. So you normally get the award letter, and then within a day or two, normally it's within the day, you receive an email from the awarded facility folks to sort of start setting up your proposal. At that same time, you will also start getting information about your scientific liaison or catalyst at either facility. And I highly recommend you use these folks. I mean, these are people who are trained scientists who have, gone the path of really helping folks use these large systems and to be as effective as they can be. They are your advocate at the facility as well. And so this can even be as simple as, trying to help you when we're doing upgrades on software, making sure things are working, helping you understand queuing and getting through, but also can be a deeper collaboration if you would like. And I highly recommend you engage with your liaison or catalyst. If you are given an award, there are some responsibilities. So the first one, and I'm sure you are all familiar with this from other things, is quarterly reports. So some status update about where you are on a quarterly basis. So what we're really looking for here is progress on milestones, problems you're having. Those are really big ones, right? So if you're not already communicating with your catalyst or liaison about issues you might be having, about making progress, this is the place to put it. We also ask in this quarterly report just to give us some, if you've had any publications or posters or awards, etc., about work related to what you're doing, to please let us know. Because one of the other things in terms of PI responsibilities is to work with us on providing highlights for your scientific or engineering accomplishments as they occur, or technical accomplishments as they occur. As was mentioned, right, the way we basically pay back, having these facilities, the way we justify their existence is through the scientific accomplishments. So we have to be able to discuss these. We are absolutely sensitive to things that are embargoed until publications are public, etc. But it is necessary. We have to do this. This is a lot of my life is summarizing, what kind of science we've done on these systems and what kind of science we're going to be doing. So engaging with us on providing those highlights is very important. So please. And frankly, it tends to promote your work, right? And get it into a higher profile. If you were given a multi-year award, you do need to submit a renewal request. No renewal is automatic. You absolutely have to submit the renewal proposal in July. So please be aware of that. If you have any concerns, like you thought you were renewal, but you haven't been given instructions, reach out, please. We've tried to make sure that every single person that is eligible for a renewal this year has acknowledged that they know how to do that and that they will. In addition, you'll be asked to do some by whichever facility you're using to complete some annual surveys. These are, again, very necessary. These aren't ones we do just because we want to make you fill out something more. These are part of the ways that we justify to the DOE that we're actually doing our job. And the annual survey is an annual requirement for the facilities. In addition, I will also encourage you to ask your team to be good citizens, not just to use the resources for the proposed work, which is really important, but also, to work within the rules we've set up on the facility. So whether it's queuing policy or what have you, to be kind and know that it is a shared resource. We will work with projects to make sure that they are successful. If you're having problems or struggling with policies or whatever it may be, but try not so much. Please encourage your projects to not your folks to not game the systems too much. But really, the real key thing here as a PI, I ask that you let us know about your achievements and your challenges. That's really the key thing here. All of this is to make sure we understand if you're having a problem, let us know. And even if you think we can't help, right? Like just let us know. And then we know where you are, and we're not going to necessarily panic about your project. But we can always increase, say, the level of resources if you're having a challenge in order to help you be successful. But also let us know about your achievements. Those are fantastic. And as I said, it's not just your science research achievements. Sometimes it's even the technical ones, like, performance improvements you've made, things akin to that. We'd love to hear those, and those are really valuable for us. We also ask, we do have user meetings. We have training available for the teams. Both facilities do. I encourage you to please send your folks as much as you are able. This helps partly with being a good citizen and everything, but it also really helps people being a lot more fluent in understanding the resource that they are using, and helps be much more effective over the course of the year. And not surprisingly, when you do publish work that is from your INCITE award, we have acknowledgements that we please ask you to include. There is a general INCITE acknowledgement, then also an acknowledgement for the specific facility that you are using. Those are very important. So please include those in those publications. And very, very last, right? It's a small world. And what I mean by that is, program managers talk even across agencies. So let the agency that funds your work know that INCITE was valuable, that you have this time, that you are able to be getting, some of your research done because of it. Please communicate that. And that sort of helps, I think, build the ecosystem, right? And creates the leverage to make these even more available for folks. As I mentioned, please contact us if you have questions. I really like this time of year. It's all about questions from potential PIs and from current PIs. making sure that, you know the ins and outs and what to do next. So please contact us. And this is it. So this is the last slide. It's just some contact information for everybody. In particular, beyond the contact for the INCITE office, this is how you can get help and get help for either ALCF or OLCF, and specifically ask for the discretionary time from the OLCF or the ALCF. So these are here. These slides will be posted, but as mentioned, like if you go to the sites for either facility, you should be able to find that pretty straightforwardly. All right. I will pause again for questions. And at this point, I'm happy to leave it a little bit more quiet for questions to come in. I know we're a few minutes late, but I do want to make sure to get those answered. All right. If there are no questions, I will let everybody go. And thank you very much for joining us. And please remember that we are here. Email questions are great. I have no issues with those. But please don't feel any sort of nerves about asking the questions. It's far easier to ask and get the answer than to worry about whether you're doing the right thing.